Now, we will discuss moments. We know that several times whenever we collect data, we ask some of the summary statistics to understand the data. For example, averages, then variability, variance. So, what are those things? So, usually when in a class some marks obtained by students, student usually asks that what is the average of the total all the marks. So, then the student can understand that the data how it is, all marks how it is situated. So, one that average only not cannot be only measure to understand the data. There are many other measures also it is required to understand the data. So, here we will understand, we will learn it that what are the measures. So, whenever we are collecting data, so we have some kind of data like that x1, x2, some n number of data. So, we assume that this data coming from a particular distribution, it follows some distribution. Distribution in the nature we do not know, it is some phenomena that we want to estimate or we want to find that. Usually we assume that it has some distribution. So, there is some possibility that this x1 can come, some probability that x2 can come. It discrete, then there is some assigned probability that what is the probability of x is equal to xi. Now, usually we do not know this probability, what do we do? We have a data, then we find the average, this is called the sample mean, this is 1 by n x1 plus x2 plus xn. So, that means we just sum it, what is the value, and n, this is called the sample average. So, if you write it in a different way, same thing, it is nothing but like this. So, what is this? It is the value. So, this is the value of the observed value of the data and x1 and n is the, so 1 by n it is multiplied. So, then it has we take the sum. So, what is the 1 by n here? So, 1 by n is seems like it is we are considering that the some kind of weight, and that weight are same, n number of elements are there, all weights are 1 by n. Now, if the data contain multiple observations of same, so suppose x1 it is coming m1 number of times, x2 it is coming suppose m2 number of times, and xn it is coming mn number of times. So, then what will be the average? So, if you take the sum, then x1 plus x2 plus xn, but it will be repeated. So, because this data contains m1 number of x1. So, this x1 plus m1 times plus x2 plus x2 plus x2 m2 times like this. Then total, suppose total number is nothing but m1 plus m2 plus mn. So, then like this xn plus xn plus xn mn times. So, then this sample average will be like this. This is nothing but by total n. So, this is nothing but m1 into x1 plus m2 into x2 plus mn into xn by n. Now, if you write it is in a different form, it is nothing but m1 by n x1 plus m2 by n x2 plus mn by n xn. Now, what was those weight? So, this is some kind of weight. So, you can write like p1 x1 plus p2 x2 plus pn xn. So, this weight actually, this is nothing but if you have a some kind of classical approach, if you know some in the box some balls are there, suppose x1 like some particular color m1 number of times and x2 is some different color m2 number of times. Now, if I ask you what is the probability that this particular color x1 color that will appear when like this mn number of balls are there. So, by classical approach you know that this probability that this color x1 will be nothing but m1 by the total number of balls, it is nothing but n. So, this is nothing but p1. So, this average actually what it is coming, it is nothing but the probability that that value it come plus probability that that value of the observation like this. So, that is why this is nothing but the average, sample average. Now, usually we whenever it is not repeated observation, because it is only one, all the x1 or 1 we are assuming, by classical approach all has same probability we are assuming here. But if you know the exactly what should be the probability, if you know the in which distribution it is coming, this probability suppose that we write is probability px of xi, this is nothing but suppose I denote the value pi. So, if you know the probability, it is the actual distribution, if you know, then what will be the expected value or the sample, this average. So, that is called the population mean, because population is the population means that we are, if you consider all the data and all the possible that all the points in the sample space, and then if you take the average. So, that means you know that what is the probability that x1 should come, what is the probability that x2 can come, and then you can take the weighted average with their probability. So, that is called the population mean, and that population mean is defined by, so it is nothing but sample mean, and then the population mean is defined by, suppose you know the discrete distribution. So, this is nothing but whatever the value it can take xk, and then px of xk, px of xk is the probability that value it can come, and summation over k. So, k can be a number, because discrete distribution k can be infinite. So, k it is a finite, then it will be finite sum, and if it is infinite, then it is infinite sum, provided it will be absolutely summable. If it is not summable, then this infinite series is not summable, then this does not exist, this mean does not exist. So, this is called the population mean. So, that we will discuss here. In general case, let x be a discrete random variable with probability mass function, we say probability mass function pxx. So, whenever x is belongs to the range of x. Okay. So, range of x is nothing but x1, x2 like this. It is finite, then after sometimes it will be xm, otherwise it will be countably infinite only. So, then what is the mean of x. So, whenever we say only mean, it is nothing but the population mean of x is defined by expected values of x. It is actually denoted by expected value by x, sometimes we denote mu x. So, for some of the book it is followed mu x dash, it is not derivative, because there is another moments mean or that is called central moments. So, that is why we denote like this. So, mu x dash mx, or sometimes we denote mx also. This is nothing but summation of xk into px of xk k over k whenever x is discrete. Now, whenever if it is continuous, we know that if x is a continuous random continuous random variable, then probability at a point is 0, and in that case this is analogous, this mean is defined analogous to the discrete. The sum is replaced by the integration, and this x will be multiplied, xk will be multiplied by x with the probability mass function will be multiplied by probability mass function would be defined replaced by the probability density function. So, which is equal to minus infinity to plus infinity x fxx dx whenever x is continuous, x is continuous. So, this is the mean. So, we will discuss some of the examples. So, let us go back our discrete random variable, some of the example we discussed. So, you can remember. So, we discussed some of the discrete random variable here. Suppose here this is the discrete random variable, one example. So, let us consider, suppose this example, it is taking the range is -1 0 1 with probability mass function 1 by 3 xk is belongs to -1 0 1. So, in that case what will be the mean of this random variable? So, let x be the probability mass function, let x be a discrete random variable with probability mass function Px(x) is equal to 1 by 3 whenever x is belongs to minus 1 0 1, it is equal to 0 otherwise. So, basically this xk values are x1, x2, x3, x1 is minus 1, x2 is 0 and x3 is 1. So, it is a uniform distribution because all are having probability, same probability. So, what will be the expected values of x? So, then this mx will be, expected values of x will be nothing but summation of xk px of xk by this definition. So, then this is nothing but xk is minus 1 into probability that it can take the value minus 1 plus 0 into probability that it can take the value 0 plus 1 into it can take the value 1. Px of 1. So, then this is nothing but, see that this is 0 and this is Px of minus 1 is because it is a 1 by 3 only. So, minus 1 into 1 by 3 plus 0 plus 1 into 1 by 3. So, 1 by 3 minus 1 by 3, this is equal to 0. So, mean is 0. So, now let us discuss one continuous random variable, how to find the mean of this continuous random variable. Let us consider, let suppose this again suppose let, so let x be a continuous random variable with the probability density function given by, so let us consider one of the density function we discussed, suppose c by x square, no, this is not the, we will discuss at the beginning what we discussed. So, this is nothing but this example f(x) is equal to 3x square by 28 whenever x is between minus 1 and 3, it is 0 otherwise. So, these things we will discuss. So, f(x) is equal to 3 by 28 x square whenever x is greater than minus 1 less than 3, it is 0 otherwise. So, what will be the expected values? So, the expected values mu x dash, expected values of x, it is same notation, just different notation, different references you will find, that is why I am writing this. So, by definition of the expected value, it is nothing but minus infinity to plus infinity x f(x) dx. So, this is nothing but minus infinity to plus infinity x 3x square by 28 dx. So, see it will not be minus infinity because this density is 0 outside minus 1 to 3. So, that is why it will be 0 automatically multiplied with this 0. So, this is nothing but minus 1 to 3. So, then it is nothing but 3 by 28. Now, x square become x cube minus 1 to 3 dx. So, this is 3 by 28 into x to the power 4 by 4 minus 1 to 3. So, this is nothing but what will be the value. So, this is 3 by 4 into 28 into x to the power 4, the limit 3, this is nothing but 2781, and then minus 1 whole to the power, this is okay, this is minus 1, this is minus 1. So, whole to the power 4. So, I hope if there is any mistake, you please check it. So, then this is nothing but 3 into 80 by 4 into 28. So, then just this is 220. So, 20 into 3 60. So, this is nothing but, so we can again this is, so then 15 by, this is nothing but 15 by 7. So, this mean of this continuous random variable is nothing but 15 by 7. Now, let us two data set, let us consider two data set, two random variable, like suppose you have two data set like that, uniform random variable suppose you are considering. So, one is that random variable, suppose discrete random variable, suppose we have already considered one random variable like this is the example of this f(x) pxx is 1 by 3 minus 1 0 1. So, let us take another similar type of random variable, but just taking different range of the. So, here Rx is range of this random variable, suppose another random variable is y. So, y is a random variable with range of y is, suppose range of y is minus 10 0 10, and then the what is the probability mass function? Probability mass function that p of y, this is nothing but y is equal to y, which is nothing but 1 by 3 whenever y is belongs to minus 10 0 10, this is equal to 0 otherwise. So, note that this random variable taking different values, one similar values, and the random variable x in here we discussed, here this discrete random variable, it is taking minus 1 0 1. So, now if you take this mean of this random variable, expected values of y, so this is the mu y. So, this is nothing but what will be the mean? So, by definition summation of it will be yk, p of yk over k, here are three values it is taking. So, this is minus 10 into poi of minus 10 plus 0 into poi of 0 plus 10 into poi of 10. So, then this poi of minus 10, this is 1 by, all are 1 by 3. So, that is why this is 1 by 3 plus 0 plus 10 into 1 by 3. So, this is equal to 0 again. So, both the random variable has same mean. So, that is why if you have two data like this, so you can see that one data is like the 0 minus 1 and 0 1, and another data is like that, suppose minus 10 is here and this is 10 is here. So, then you can see that one data situated like this, another data is like this. So, suppose one class students getting marks, it is very close to 0 like this. It is not exactly, so one data it is minus 1 0 1 and another like minus 10 10. So, these are different data, but having same mean. So, the in the what just we want to discuss here, that giving the mean of a random variable is not enough for understanding the data. So, it will just give a some kind of central tendency. Mean is nothing but a central tendency, average behavior of a data. So, different data, different distribution may have same mean. So, we need to learn some more summarized some of the other measures also of a data. So, in general we will write, suppose if you consider, so another concept here we are introducing, we will discuss in details later. It is called a function of a random variable. So, you know a function, suppose y is equal to some f of x, some other function, let us f already we are using for density function. So, some g of x. So, it may be sin x, so any function, suppose this is x equal x plus 2. So, then if we ask that, so if you this is a function from this function g is from this function g is from R to R. So, we can talk about instead of a real number here, if you make the random variable. So, what will be that things g of x. So, because x is already a measurable function from S to R, it is a Borel measurable function. If you take a function gx, so basically it is going like there is a S here, this is R here suppose. So, this is the x is a measurable function, and then R to R you are taking another function g. So, then if you consider this composite function g of x, so that means any point S here, how it is going, x of S will be in a real number. Then you are talking about, so g is R to R, so g of x of S. So then it will be again a random variable. So this will be a composite function y. Y is nothing but g of x. So basically it is defined by g of, so y of a point in sample space, y of a point in sample space, then this is nothing but g of x of s. So it will be again a measurable function, because if you consider g is r to r, a particular function, so that it will be a measurable function here. So then y is equal to g of x will be again a measurable function. So if you take a type of transformation, then we can talk about by either you have to find what will be the x is having some kind of distribution, then what will be the distribution of y, and with respect to this distribution we can find their mean. Now we can instead of that, using this distribution of x directly, so later chapters we will discuss that in the transformation of random variable, how to find the distribution of y whenever you know the distribution of x. So here we will not go to, we will not find the exactly what is the distribution of y. What we will do, we will just find the, by this transformation, what will be the mean of y. So why we are discussing here, it has some advantage, we will generalize some kind of this kind of measure. So then what will be the expected values of y? Expected values of y will be, by definition, suppose it is a this is a suppose this is a discrete random variable. By definition, this is nothing but summation of yk, and this is taking all the value, it is taking yk. This is the definition. Now because it is expected values of y is nothing but expected values of y is equal to gx. So now we will define how expected values of a gx we can find with respect to the distribution function of x. So expected value of gx will be defined by, for discrete case, it is nothing but k, what is the value it can taking, g of xk, and then it is probability that it can take the value xk. So for continuous case it is defined by, so minus infinity to plus infinity, so g of x f x x density multiplied by density x. So this is whenever x is discrete, and whenever it is a x is continuous. So now why we are defining this? So it is a general definition. So basically this is nothing but expected values of y. So this expected value will be same, this later we will discuss, we will find that also, but here we are going not finding this probability mass function in case of discrete case, and continuous case we will find the probability density function. We are not finding those things, just we are defining whenever we are taking a transformation like y is equal to g of x. So then we can directly find expected values of gx. Expected value of gx is nothing but what is the value it is taking under the transformation gx, and the probability that actually this probability does not change, only the value changing by the g. So as if, like suppose if you think that in a intuitive way, suppose this head and tail, observe head and tail, some probability of head is 0.8, probability of tail is 0. So that means probability that this, now if you define this random variable, x is like whenever head observe this is 1, and whenever tail observe this is 0. So this is 0. So now we understand that this, under this random variable, suppose our distribution is x is equal to 1 means head observe, probability that head, suppose this is 0.8, and probability that x is equal to 0, this is nothing but probability tail observe, this is 0.2. So this is the probability mass function of this random variable. Now if you take a transformation y is equal to gx, this is nothing but x plus 2. So then whenever x is 0, if x is equal to 1, then y is equal to nothing but 2 plus 1, this is nothing but 3. Now if x is equal to 0, then y is nothing but the 0 plus 2, this is equal to 2. So that means whenever x is equal to 1, so which implies probability that y is equal to 3 is same as probability of x equal to 1, and this is equal to 0.8, and if y is equal to 2 is nothing but same as probability of x equal to 0, this is equal to 0.2. Now if you find the these expected values of y, so suppose if you want to find expected values of y directly from the distribution of y, So, here you can see that the distribution of y is nothing but what is the probability mass function we are getting. Probability mass function of y is P of y. This is equal to, it is nothing but probability that, so it is directly it is written here. So, it is 0.8, this probability is 0.8 if y is equal to what is the value y, whenever y is 3, then this is nothing but probability of head is 0.8. So, basically under y, so this is 0, 1, 2, 3. Basically head observed means under y it is 3 observed, and head tail observed means for y it is 2 observed. So, basically it is y of head and this is y of tail. So, that is why y is equal to 3 means head observed. So, probability does not change, only the value changed to 3. So, that is why here y is equal to 3, probability is same and it is 0.2 if y is equal to 2. So, what will be the expected values of y? Expected values of y will be summation of yk p of y yk. So, then summation of yk is nothing but it is taking the value 3 and 2. So, this is nothing but 3 into 0.8 plus 2 into 0.2. This is yk is 3, probability of y is equal to 3 is 0.8. So, then this will be nothing but 2.4 plus 0.4, this is nothing but 2.8. Now, if you find by this formula expected values of only gx, so this is nothing but expected values of gx is by definition this is nothing but summation of k g of xk p of xk. So, here we are keeping the probability mass function of x. So, then what is the value x can take? It is nothing but 0 and 1. So, this is nothing but g of 0 into px of 0 plus 1 it can take g of 1 px of 1. So, now what is g of 0? G of 0 is nothing but gx is nothing but x plus 2. So, whenever it is g of 0, so this is nothing but 0 plus 2, 2. 2 into px of 0, px of 0 is nothing but x is 0 means tail observed it is 0.2. So, this is nothing but 0.2 plus g of 1 means x plus 2 plus 1, this is nothing but 3, and px of 1 means with respect to random variable x equal to 1 means head observed, this is nothing but 0.8. So, it is 0.8. So, again it is coming 0.4 plus 2.4, this is nothing but 2.8. So, that is why this formula we can use instead of finding the details of the distribution. So, sometimes it will be required because here only we are finding the mean, but if whenever we are interested to know the actual distribution function of y, so then we need to find the distribution function in this way. So, later we will discuss more details. It is very easy, it is only head and tail only, head and tail, that is why it is easy to find and we can verify this.